Potential warnings of an imminent volcanic eruption are mounting in Italy following the detection of hundreds of tremors west of Naples over recent weeks. In the past several days, the city of Naples has been rocked by a dramatic and unsettling sequence of seismic events. It feels as if the Mediterranean's long-dormant titans are stirring, prompting fears of a dual volcanic crisis. Imagine receiving a sudden alert on your device, an ominous message about a massive volcanic eruption near Greece, followed by a tsunami warning. And before you have a chance to process it, another notification declares that a supervolcano has awakened in Italy and that an emergency has been declared in Naples. At first glance, these reports seem lifted straight from a Hollywood disaster epic, a worst-case scenario plucked from science fiction. Yet what if, right now, as you read these words, two of the Mediterranean's most formidable volcanic giants are simultaneously showing signs of unrest? These are no ordinary volcanoes. One of them, Santorini, is not merely a scenic island, but the shattered relic of a cataclysmic eruption so immense that it may have annihilated the entire Minoan civilization, seeding the legend of Atlantis. The other, known as Campi Flegrei, is an immense hidden supervolcanic caldera beneath Naples, a behemoth capable of unleashing devastation upon the city and dispersing ash clouds across Europe. Both of these volcanic systems are now exhibiting alarming levels of seismic activity, with the ground trembling, swelling, and seemingly whispering warnings from the depths of the earth. Scientists are scrambling to determine whether these events are coincidental or indicative of a far more sinister, interconnected process unfolding deep within our planet. Let's first consider Santorini, often described as an Aegean time bomb. Behind its postcard-perfect cliffs and brilliant blue waters lies one of the most destructive volcanic systems in recorded history. More than 3,600 years ago, Santorini experienced a cataclysmic eruption, the likes of which remain unmatched in human memory, that not only reshaped the island's landscape into the flooded caldera we see today, but also generated tsunamis, powerful enough to obliterate entire civilizations on neighboring islands. Ancient cities were lost in an instant, their ruins entombed under thick layers of volcanic ash, while vast amounts of sulfur dioxide were expelled into the atmosphere, leading to climatic disruptions that may have plunged regions far beyond the Mediterranean into prolonged darkness and famine. Some researchers even contend that this event played a pivotal role in the collapse of ancient societies as distant as those in China and the Middle East. Fast forward to the present day, and the same volcanic system appears to be stirring once again. Since early 2025, scientists have recorded an unprecedented surge in seismic activity around Santorini, detecting over 12,800 earthquakes, some registering magnitudes above 5.3. These tremors have been especially concentrated in the submarine areas encircling Santorini and the nearby island of Amoros. Satellite imagery has revealed that the ground is gradually rising, a phenomenon known as inflation, akin to a balloon swelling with internal pressure as magma forces its way upward. Concurrently, gas emissions from the caldera have spiked sharply, strongly suggesting that molten rock is on the move deep within the Earth's crust. Volcanologists caution that if these signs persist and the pressure continues to build unchecked, Santorini could unleash another cataclysmic eruption, with consequences that would ripple far beyond the borders of Greece. Turning our attention to Campi Flegrei, while the notorious Mount Vesuvius often captures public attention, it is Campi Flegrei that now occupies the minds of scientists. Nestled beneath the bustling metropolis of Naples, Campi Flegrei is a vast and complex supervolcano. Unlike the classic conical silhouette of Vesuvius, Campi Flegrei is an immense caldera spanning roughly 8 kilometers, a veritable cauldron of churning magma simmering beneath the surface. Its history is marked by eruptions of staggering ferocity. Around 39,000 years ago, it is believed to have unleashed one of the most powerful volcanic explosions in European prehistory, an event so immense that it may have contributed to the extinction of the Neanderthals and left a layer of ash detectable as far away as Russia. More recently, in 1538, the very ground near Naples split open, spewing molten lava and giving birth to a new mountain known as Monte Nuovo, a vivid reminder that Campi Flegrei is far from dormant. Current monitoring of Campi Flegrei is cause for deep concern. Researchers have noted that the ground in this region is rising at an alarming pace of approximately 1.5 centimeters per month, clear evidence that magma is steadily advancing toward the surface. This slow, almost imperceptible motion, referred to as bradyseism, has been observed over several decades. However, its recent acceleration, coupled with a spate of seismic events, has alarmed experts. In February 2025 alone, the area experienced more than a dozen earthquakes, including 2 tremors of magnitude 3.9 that were felt as far away as central Naples. Moreover, abnormal gas emissions laden with high levels of carbon dioxide and sulfur have been detected, and even nearby water bodies have begun to bubble ominously, a classic signal that subterranean gases are escaping. Local authorities have promptly issued warnings to residents in high-risk zones, emphasizing that an eruption of Campi Flegrei would be catastrophic. Naples could be buried beneath thick layers of ash, essential services could collapse, and European air travel might grind to a halt due to pervasive volcanic debris. The economic and climatic ramifications of such an event would be profound, potentially echoing the global cooling observed after the 1815 eruption of Mount Tambora. The simultaneous unrest observed in both Santorini and Campi Flegrei raises a provocative question. Could these two seemingly disparate volcanic systems be interconnected by deep, unseen forces within the Earth's mantle? At first glance, Santorini and Campi Flegrei appear to be worlds apart, separated by over 1,000 kilometers of the Mediterranean Sea. Yet, emerging research suggests that large-scale magma movements beneath the Earth's surface can indeed influence volcanic systems separated by vast distances. A groundbreaking study from 2018 indicated that the movement of molten rock deep within the mantle might generate enormous changes in underground pressure, potentially triggering seismic activity in regions far removed from the original source. In essence, a significant surge of magma beneath one volcano could destabilize another, even if they are geographically remote from each other. Furthermore, both Santorini and Campi Flegrei are situated along tectonic subduction zones, where one tectonic plate is gradually forced beneath another, a process that is fundamentally responsible for much of the volcanic activity in the Mediterranean region. Seismic and geochemical investigations have even revealed that both regions emit gas compositions and seismic patterns that bear striking similarities, hinting at the possibility of a shared magmatic reservoir. If this connection is indeed real, then disturbances in one volcanic system might have far-reaching consequences for the other, setting the stage for a chain reaction of volcanic events that could radically alter the region's geological landscape. Another intriguing aspect that scientists are currently exploring is the role of deep magma plumes, rising columns of molten rock that can traverse vast distances within the Earth's mantle. These plumes, which sometimes originate as far down as the boundary between the Earth's core and mantle, create localized zones of partial melting that can feed volcanic hotspots. The Hawaiian hotspot is perhaps the most famous example of such a phenomenon, but recent studies are investigating whether similar large-scale interconnected magma plumes exist beneath tectonic plate boundaries, potentially linking distant volcanic systems like Santorini and Campi Flegrei. By meticulously analyzing seismic data, geochemical signatures, and employing sophisticated computer models, researchers are striving to determine whether a shared deep magma source might be influencing both systems. Should such a connection be confirmed, it would not only revolutionize our understanding of volcanic mechanics, but also pave the way for more effective early warning systems, enhancing our ability to predict and mitigate the impacts of future eruptions. Complicating matters further is the emerging evidence that climate change could be playing a role in modulating volcanic activity. The rapid melting of polar ice caps and glaciers reduces the pressure exerted on the Earth's crust, a process known as isostatic rebound, which can destabilize underlying magma chambers. This phenomenon has been observed in places like Iceland, where a clear correlation between ice loss and increased volcanic eruptions has been documented. Additionally, the global rise in sea levels, driven by thermal expansion and melting ice, may alter the hydrostatic pressure on the ocean floor, thereby affecting volcanic systems in the Mediterranean. Extreme weather events, such as heavy rainfall and flooding, can further exacerbate these effects by infiltrating the Earth's crust and triggering phreatic explosions, a type of eruption where water rapidly turns to steam, causing violent, unpredictable blasts. Although the aerosols released during volcanic eruptions can induce temporary global cooling, these effects are fleeting in comparison to the long-term warming induced by greenhouse gas emissions. Understanding how climate change interacts with volcanic processes is essential for accurate risk assessments and for preparing vulnerable regions for potential disasters. As we piece together these complex interactions, the evidence appears to be mounting that the Mediterranean region may be on the cusp of a new era of volcanic activity. Santorini is rumbling ominously beneath the Aegean Sea, while Campi Flegrei is swelling beneath the bustling metropolis of Naples. Historical patterns indicate that volcanic eruptions are not random events, but are part of cyclical processes driven by deep-seated geological forces. Some of the most catastrophic eruptions in recorded history have been preceded by prolonged periods of relative dormancy, a deceptive calm that belies the tumult building deep within the Earth. If a large-scale eruption were to occur in either of these regions, the immediate consequences for the local population would be devastating, and the ripple effects could extend far beyond the Mediterranean, potentially altering global climate patterns, disrupting air travel, and triggering economic upheavals reminiscent of the aftermath of the 1815 Tambora eruption. The question that now looms large is whether these observed tremors and gas emissions are merely part of the natural, albeit dramatic, cycles of Earth's restless interior, or if they herald the onset of a catastrophic chain reaction that could engulf the entire region in fire and ash. Are we witnessing the natural rhythms of an ancient Earth readjusting itself? Or is there a more profound, interconnected process at work, one that could precipitate simultaneous eruptions from both Santorini and Campi Flegrei? The possibility of a domino effect, where the awakening of one volcano triggers the destabilization of another, is both tantalizing and terrifying, and it has spurred a new wave of research aimed at deciphering these complex interactions. Recent advances in monitoring technology have allowed scientists to track subtle changes in seismic activity, ground deformation, and gas emissions with unprecedented precision. These tools are critical for discerning whether the current signals are indicative of an impending eruption, or if they simply represent minor fluctuations in a long-dormant system. Yet, despite these technological strides, significant uncertainties remain. The interconnected nature of deep Earth processes, the influence of external factors such as climate change, and the inherent unpredictability of volcanic systems all contribute to a complex puzzle that researchers are only beginning to solve. The stakes could not be higher. For the nearly 3 million people living in Naples and its environs, the potential eruption of Campi Flegrei represents a ticking time bomb, a scenario where dense urban populations, critical infrastructure, and vibrant cultural heritage could be overwhelmed by a sudden, catastrophic event. Likewise, another eruption at Santorini would not only devastate the local communities, but could also disrupt tourism, a vital economic driver for Greece and the broader Mediterranean region. Moreover, the atmospheric consequences of such eruptions, ranging from localized ash fallout to global climatic anomalies, could have far-reaching impacts, affecting agricultural productivity and triggering economic disruptions on a continental scale. In light of these concerns, many scientists are urging for increased international cooperation, improved data sharing, and the deployment of more advanced monitoring systems. The establishment of integrated early warning networks that combine seismic, geodetic, and geochemical data is seen as essential for providing timely alerts and mitigating the risks associated with these potentially catastrophic events. Collaborative efforts that span national borders and academic disciplines are crucial for developing a comprehensive understanding of these deep Earth processes and for crafting effective strategies to safeguard populations in the affected regions. So where does this leave us? As Santorini continues to show signs of reawakening and Campi Flegrei steadily swells beneath Naples, the Mediterranean appears poised on the edge of a geological transformation. The emerging evidence suggests that these volcanoes might not be isolated phenomena, but could be part of a larger, interconnected system influenced by deep mantle dynamics, tectonic forces, and even climate change. While it remains uncertain whether these signals will culminate in a full-scale eruption or simply mark another cycle of Earth's natural activity, the implications are profound and demand our utmost attention. Are these tremors and gas emissions merely a manifestation of Earth's natural rhythms? Or are they harbingers of a more dire, interconnected volcanic upheaval? As scientists continue to unravel the mysteries of these ancient and powerful systems, the need for vigilance, preparedness, and international collaboration has never been more apparent. The fate of millions and the stability of an entire region may well depend on our ability to decode the subtle signals emanating from deep within the Earth. What do you think? Are we simply observing the natural ebb and flow of geological activity? Or are we on the brink of witnessing one of the most significant volcanic events in modern history? Share your thoughts in the comments, and be sure to like, subscribe, and turn on notifications to stay informed about the latest developments on this unfolding geological drama.